Yeah, I think we're down some voltage there or something. Pretty blurry. Definitely better. So we'll stick with this too. Hello again, everyone. Welcome back to the basement shop. Today I'm going to be building a CRT clock. Most of you have seen these. They're digital clock that works with the old CRTs. So I ordered this kit. This is everything you need to make one work. Circuit board, all of our parts, transformer. This kit's designed to be used with a 3-inch or smaller electrostatic CRT, like the one shown here. Now the 3BP1 is a 14-pin. You've seen me use it I'm working on an electrostatic TV. Use it as a test CRT. The 3RP1 is a 12-pin. And I've got something kind of special in mind for this clock whenever I mount the CRT in a case and make it a permanent housing. We'll cover that later. Right now we're going to start populating it with parts and build this kit. All the resistors and caps and chips are all labeled on the board. There's 6 pages here that I printed out, and we're just going to do these in the steps that he's showing here. And it tells you, like the resistor, that's a 10 ohm 3 watt, the diode, caps, etc. Well, here's all of our parts. Just dumped them out here on this white towel so I can easily see them. Resistors, we'll have to find the correct resistor, and even after I look at the color code, and I'll also test them with the meter before we put them on the board. So let's get started. I have the parts populated, and we're to the point where we need to test to see if we have any voltage coming out of the transformer. This is kind of crude the way this hooks up, but we can work on that if we want to make it look a little neater. This transformer just has wires that you solder directly to the board. That's okay, as long as it works. So we're ready to plug it in. First, the LED should light up, and then we want to test for 5 volts. And that test point is right here. 5 volts plus, 5 volts minus. First, we'll see if this LED lights up. So we're on the power, right? I have just a AC cord jumpered in. Let's see if we get anything. Yep, we got a LED. That's 70 volts AC. There's 100 volts. I'm drawing practically no current because we're not really doing anything here other than just checking to see if the power supply is working. Now let's check for 5 volts. I think you can see my meter. Well, maybe not. Turn it like that. Okay. So minus 4.98. least in the power supply section, they're working. Now we need to hook up our wires to the CRT. And let me show you what I'm going to use on this. This is a 3-inch scope CRT. You notice it has a perfectly flat front. Kind of wanted that rather than the test CRTs that the 3 BP ones. They have a curved front. And I took this out of a scope. There's a socket I'm going to use. This kit does come with some wire. It's pretty light, but I guess it's heavy enough. It will work apparently. I'm going to use that just to test it to see if we can get it to work. Then if it does work, we'll probably put some heavier wire than that. You'll notice in these instructions it says solder a wire to K P3 wiper for the CRT cathode. This is my tube I'm going to be using. We see K is pin 3. So we just got to match up wire A would be pin 8 and so forth. How about that? This kit does alternate between the numbers or the conventional clock face. Now I got some adjusting to do, but this is just to temporarily wire it in. See that mass of wires there that goes to the CRT socket. But everything is working. I'm going to do a little bit more reading here and we'll see what the setup procedure is. And I'll tell you what my plans are to display it. Well, I was able to figure out how to set the time. That's correct. You'll switch here in a second. 5:42, that's the correct time. You'll also notice the display shifts. And that's to prevent burn-in on the CRT. You can see it shifts to the right, to left. Even the digital display, it moves a little bit. I'm going to try the 3BP1 picture tube in place of this one. For curiosity, I'm just going to see if that 3BP1 is a little brighter. I did hook it up on a working chassis and it has a bright picture. So let's see if it's going to produce a little better image than this one does. Now, I won't have to do any rewiring here on the board. I think I can just unplug this old tube, run jumper wires from this socket over to the 3BP1. Now, this is a 12 pin where the 3BP1 is, of course, a 14. Just do it with jumper wires rather quickly and we can just see if there's a difference. All right, jumper wires directly to the back of the 3BP1. Here we go. Well, you definitely need to do some adjustments here. Well, I don't know. It could be there was a note in the instructions said you could probably run a 12-inch wire with no issues, and we're probably 18 inches from this circuit board. Later, I was able to get the 3BP1 to work. It was a combination of the filament voltage and I think putting the heavier wires on the socket as I'm about to do. I think that helped also. But it did work, the 3BP1. It was okay. Not quite as good as the 3RP one, but it did work. I guess we'll just stick with the 3RP one come out of the scope. Yeah, definitely better. So we'll stick with this tube. Next, I'll be changing the wires going from the board to the CRT socket. And here's the wire I'm using, 20 gauge, 600 volts. And I have several different color jackets, so I'm going to try to use a different color for each wire. And we'll replace all of these small ones. All right, I think that looks a little better. And I even put the transformer wires, fasten them down a little better. Of course, this has a nut, a washer, and an insulator that we can mount this on the chassis. Still working fine. Set the time, you push the fast button or the slow button. This is what I'm going to mount the clock in. This is an RCA Institute scope. The 3RP1 CRT that I'm going to use came out of this scope. So it'll be a simple matter just reinstalling it. We can mount the circuit board either on top, or I may have to take some more stuff out here and mount it underneath. I think that's going to look pretty sharp, but as you can see, we've got a little issue there. You put the CRT back in the scope like it came out, display's not up and down, so I had to remove these two brackets that went around the neck of the CRT, and we'll turn it to where it needs to be and mark it and put the brackets back on. 12 o'clock position. We may need to move the 6 over just a little. But we're close, and I have the bracket reinstalled so the tube's tight. We do need access to 3 switches. This is a fast and slow set for the clock. And then we've got a switch on the sides called a toggle switch. Possibly we would need that sometimes. So what I would like to do, I have 2 switches here. These are on or off. They're not momentary contact like I would want. But I would like to mount a switch here and here with a fast and slow set. Controls, I can set those. There's actually 7 potentiometers, but I can get those set and seal this up, and they shouldn't have to be changed then. So I'm going to see what I can come up with for these switches. Well, it's a simple solution on the fast and slow. These switches will work fine. It's to set the time. That's fast and slow, and you can stop it in plenty of time within a few seconds. So those will work. I have jumper wires connected right now. What I'll do is just run 4 wires, tack them in right here where I have the jumpers, and I'll leave the switches on the board. Won't hurt a thing. Now we got to figure out that toggle switch, what we can do there. All right, I'll show you what I've come up with. First, I've removed all the tube sockets, anything that's on top of the board. This is my insulator that will go underneath the circuit board. And then I'm going to put a screw in this side and this corner back here. He has a hose prepared there. All you gotta do is enlarge them so there's no circuitry in the way. And here's the AC input wires. They'll go down through that hole right there. Come up with some kind of a grommet I can put them through. And they'll attach to the fuse. And of course the AC cord on the scope. So I need to go get a drill and a bit, and we'll see if this idea works. 2 holes bored. I have my holes in my insulator. I have the holes bored in the circuit board. Just a couple of plastic washers between the circuit board and my insulator. Circuit board is mounted, and I put 2 plastic insulators under each screw. That keeps it well above that cardboard, and I don't think we'll have any issues with it causing a problem. Still working. And these are my 2 toggle wires for the toggle switch. And these are the fast and slow set wires coming out here. They'll go down to those 2 on the front. Grommet where the AC input wires go through the chassis. And we're hooked up underneath. I'm even using the original fuse. And look at all the parts I had left over here. Several good tube sockets. Sometimes they'll come in handy, so all types of hardware. There's some screws. And we got lots of screws and nuts over here that I took out of those tube sockets. If you're seeing a flicker on the screen, that's just different frame rate between the cell phone camera and the scope clock. But there's no flicker at all when I'm looking at it. All right, got my slow and fast set switches hooked up. That's slow, fast. I'm going to set the time and leave this plugged in, let it run for a while. Make sure everything's okay. Then we got to figure out what we're going to do with this toggle switch, the 2 wires to it. So I won't have to be taking the case off to get inside this thing to do any adjustments. Pretty happy with my install. Need to probably just tape that to the CRT like that. I think everything else is clear. Maybe pull transformer wires up like that. There's where I mounted the transformer. I didn't cover that, but there's a space right there. And I can still get to the controls on the circuit board. There's 5 and then 2 on the end. I'll make sure those are all set before we button everything up. Fasten that CRT harness down. Still looks like a scope. The clock's been running almost 2 hours, so we're good. And here's a solution on that toggle switch. We have an on-off switch here on the scope that's not being used. So I'm just going to wire that toggle switch up to the on-off switch. And that on-off switch worked perfectly for the toggle switch. All right, everything put back together. One more time, I'll show you how these fast and slow switches work here on the front. This one is slow and fast. So that wraps up the video on taking this old scope and making a clock out of it. Thanks for watching. See you next time. Hope you've enjoyed the video. If you did, give us a like, comment, and subscribe to our channel. Thanks for your support. See you next time.